Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next video of mathematical methods in physics. Dear students, in this video we will solve 5 problems of vector analysis. Okay. All these 5 problems have been chosen from the book Advanced Engineering Mathematics by Dennis G. Zill. One problem has been taken from example side and remaining 4 problems have been taken from exercise side. Okay. Dear students, during the recording of this video, an attempt shall be had to keep this video lesser or smaller than 15 minutes. Okay. If this video remains less than 15 minutes, then it will be uploaded on our concerned channel, that is Mathematical Physics by Rajput Abdul Wahid Bhatti. But if duration of this video goes beyond 15 minutes, then because that channel is newly created, that channel still does not accept uploading of videos longer than 15 minutes. Okay, so if this video goes longer than 15 minutes, then this video will be uploaded on our main channel under title Physics Lectures by Rajput Abdul Wahid Bhatti. Okay, problem number 10, find the direction. Dear students, in these 5 problems, trigonometric formulas, trigonometric values are used in all these 4 problems. So in the end of this problem, 2 tables have been shown. Okay, these 2 tables will be very helpful, okay, in this connection, because these 5 problems relate to vector analysis in which trigonometric values are used. Okay, find the direction cosines and direction angles of the vector a equal to 2i plus 5j plus 4k. Okay, direction cosines and direction angles. Okay, that is alpha, beta, gamma, as well as cos alpha, cos beta, cos gamma. These things we have to calculate. First, we develop a foundation for this problem. Dear students, these basic foundation level wording will be repeated in every problem. But in order to save time, we will skip explanation of this portion. Okay. We know that for a non-zero vector a equal to a1i plus a2j plus a3k in 3 space, the angles alpha, beta and gamma between a vector and the unit vectors I, j and k respectively are given as cos alpha equal to a1 over magnitude of vector a, that is a norm or a absolute value or magnitude of a. Okay, similarly cos beta becomes equal to a2 over magnitude of vector a, similarly, and cos gamma equal to a3 over magnitude of vector a. Okay, such that cos square alpha plus cos square beta plus cos square gamma equal to 1. Okay, this is a counter check method. After finding all these 3 values, cos alpha, cos beta and cos gamma, we may add a square of all these 3 angles and it should be equal to 1. If it becomes equal to 1, then it will be a counter checker proof that our problem has been solved correctly. Okay, so dear students, this portion, okay, will be included at the beginning of every problem, but we will skip this because we have discussed in detail in first problem. Okay, so now we come forward. Now because here a is equal to this, so here a1 is equal to 2, a2 is equal to 5 and a3 is equal to 4. So this implies that a norm or a modulus or a magnitude of vector a becomes equal to 45 under root, it can be written as a 9 into 5, and 9 is a square of 3, so 3 into 5 under root. Similarly, cos alpha equal to a1 over magnitude this is, so it becomes cos alpha becomes this, cos beta equal to this, and cos gamma equal to this. We add squares of all these three and these become equal to 1, and hence our solution is correct. Now we find values of alpha, beta, gamma. Okay, when alpha is equal to cos alpha is equal to this, then alpha will be equal to cos inverse. Okay, alpha will be equal to cos inverse, equal this equal becomes this equal to this, and its value in radian is equal to this, and in degree it becomes equal to this. Okay. Okay, dear students, this value after simplification becomes this value, and I have taken value of this, that is cos inverse 0.298 from internet. Okay, that is from online converter. Okay, there may be several methods to find this value. Okay, anyhow, as you seem easy, you may adopt that method. Okay, so cos inverse, this value of cos inverse this in radian becomes equal to this, and in degree becomes equal to this. Similarly, beta equal to this, and this, and gamma equal to this. Okay, I think there should be no confusion. Quite simple. Now we come to next problem, that is problem number 11. This problem comes from exercise. Okay, previous problem had come from example. Okay, same a equal to I plus 2j plus 3k. Okay, we skip next step because we have discussed this step in detail in first part of this problem, in first problem of this video. Okay, now when a equal to this, here it means here a1 is equal to 1, a2 is equal to 2, and a3 is equal to 3. So magnitude of vector a will become equal to 14 under root, and hence cos alpha equal to a1 over a magnitude cos beta equal to a2, that is 2 over so on. Okay, when we add square of these three, it becomes equal to 1. Okay, hence our approach is acceptable. Okay, now when cos alpha is equal to this, then alpha will be equal to 1 over 14 under root, and 1 over 14 under root value becomes equal to this, and from online converter, online value giver, its value becomes equal to this in radian, 1.30 radian, or in degrees it becomes equal to 74.51 degree. Okay, similarly when cos beta equal to this, then beta will be equal to cos inverse 2 over 14 under root. Okay, and its value from online converter becomes equal to 1.01 radian, or in degree 57 point this, and gamma equal to this 0.64 radian. Okay, now we come to problem number 12. Okay, same problem, only values are different. Okay, a equal to 6 I plus 6j plus minus 3k. Okay, here a1 is 6, a1 and b1 or sorry, a1 and a2 are equal to 6, while a3 is equal to minus 3. Okay, we will skip this portion because we have discussed this portion in detail in previous problem. Okay, when a equal to this, then magnitude of vector a becomes equal to 81 under root, and this is equal to 9, and hence cos alpha equal to a1 over a magnitude, this becomes equal to 2 by 3. Okay, cos beta also becomes equal to this, because here a1 and a2 are equal, so cos alpha and cos beta will be same. However, cos gamma will be equal to minus 3 over 9, it becomes equal to minus 1 over 3. When we scale all these three value angles, then their resultant value comes unity 1. Okay, so it means we are proceeding in the right direction. Okay, now when alpha beta is equal to cos inverse 2 by 3, so alpha alpha or beta become equal to cos inverse 0.666, and its value from internet has been taken as equal to 0.842 radian. This becomes equal to 48.241 degree. Similarly, gamma value of gamma is equal to minus 1 over 3 cos this in radian, this in degree. Okay. Dear students, last two tables in the end of this problem are also very helpful. Okay. Next problem, a equal to 1 minus 3 under root k. Okay, here it means a1 is equal to 1, a2 is equal to 0, and a3 is equal to minus 3 under root. It means for beta we have 0 value, so cos beta will be equal to 0. Okay. This portion we skip this part, next this part. Okay, because we have discussed this part in the first problem. Okay, now a is equal to this, so magnitude of a becomes equal to 1 plus 3, because under root 3 square of under root 3 will be equal to full 3, that is 4 under root 4 equal to 2. So when cos alpha equal to this, alpha will be equal to this, cos beta equal to 0, and cos gamma equal to this. Okay. When we add all these, when we add square of all these three, then they become equal to 1. So it means we are proceeding in the right direction. Okay. Now when cos alpha equal to this, alpha will be equal to cos inverse 1 by 2 or cos inverse 0.50. Okay, and its value can be taken not only from internet, from online converter, but also from tables which have been shown in the end of this problem. Okay, so alpha equal to this becomes equal to 1.05 radian or 60 degree. Okay. Here it is explained that 60 degree is equal to pi by 3. Pi is it can be written as actually pi. Sometimes we take its value equal to 180, and sometimes we take its value equal to 42 by 2, that is 3.14. Okay, so 60 degree equal to pi by 3 equal to 3.14 over 3 equal to 1.04. Okay, so approximately 1.05 radian. Okay, so this step within bracket has been shown as an understanding of conversion factor of radian and degree. Okay, so beta equal to this and gamma equal to this. Here again 90 degree can be written as pi by 2, because pi is assumed equal to 180, so half of 180 equal to that is 90 degree, and here second time we will use pi equal to 22 by 7, that is 3.14, and hence it becomes equal to this, and in radian we have taken 1 alpha beta, we have taken we have taken this value 1 for okay, yes. Similarly, gamma value of gamma becomes equal to this 2.619 radian, this. Okay, this. Now last problem, here only value is changed, that is here a1 is equal to 5, a2 is equal to 7, and a3 is equal to 2. Okay, so we will skip this part. Okay, this part, because we have discussed it in detail in previous parts. Okay, when a is equal to this, then magnitude of vector a will be equal to 78 under root, then cos alpha will be equal to a1 over a magnitude, cos beta equal to this, and cos gamma equal to this. When we add square of all these three, it becomes equal to unity. It means we are proceeding in the right direction. Okay, now alpha equal to cos inverse so and so, its value is so and so, its value is 0.969 radian or 55.528 degree. Similarly, beta becomes equal to this radian and this degree, and gamma equal to this or this, and this radian and this. This is the table which is most very helpful regarding calculation of trigonometric values. Okay, we have two options. We can directly take these values from internet, as well as these two tables are also very helpful. Okay, Sine 45 degree is equal to this. So 45 degree will be equal to sine inverse 1 by 2 under root of here sine 30 is cos 30, tan 30, cosecant 30, secant 30, cot 30, etc. Here these are the angles 30, 45, 60, 90, 120, 135, 150, 180 degree, 270 degree, 360 degree. Okay, all these values are given. We can take trigonometric values from this. This is the end of our video. Till next video, Allah Hafiz.